Okay, here we go with part 5 of this video. I was really hoping to wrap this up in 4, but the camera just died abruptly in the middle of the 4th recording, so it's charged up again, and we're going for video number 5. So, we had done all our examples in the first 4. What is left to us is talking very generally about y equals a sine bx minus c plus d. These are the 4 different transformations we have available to us. So I'm going to talk about what each of them does, and then how to generally graph things in a step-by-step procedure. So I'll start with the midline. The midline is always y equals d. Right here I have this as plus d. Obviously if this is like minus 3, then that would be a negative 3 here. Your midline is negative. So pay attention to what signs are involved in these things, especially when you get to the phase shift. Before that, the amplitude. Lots of people think the amplitude is A. It is not. The amplitude is the absolute value of A. Amplitudes are never negative. They're always positive distances from the midline to the peak. After that, we have the period. I'll do the period last. I'll do phase shift. The phase shift, using my technique, the phase shift is what happens when you solve the equation the inside stuff equals 0. So if you set the inside stuff equal to 0 and then start solving, in this case you'll get bx equals c after you add that to both sides, and then x equals c over b. So the phase shift is going to be c over b. This is sort of the shortcut that I mentioned earlier. The thing you have to be very careful about with this shortcut is in this structure, c is negative, or c is being subtracted. So if you have something like 2x minus pi over 4, if you're subtracting pi over 4 and this thing looks like bx minus c, then your c value is positive pi over 4. If the problem you're working on has a plus here, like plus 1/2, or pi over 2 or something, that plus pi over 2 means that your c value is negative. That's why you have to be careful about keeping these things straight. That's why I never ever try to just do this by memorizing what c and b are using this thing. I always just set that inside equal to 0 and solve. I think this is super reliable. I think this is what you should do. It takes 10 seconds. It is not an investment. I think you should do it this way. The book will tell you this. The period is always 2 pi over b. Remember that b is the horizontal stretching and shrinking factor. So if you take the standard period and divide by that factor, it'll give you the new period. So this is the basics of all this stuff. And now I would like to talk about generally how you graph these in terms of a step-by-step list. And for that I'm going to erase all this because I want the whole board. Step 1. Find the midline, the amp, the p-shift, and the period. Step 2. Graph the midline. As a horizontal ... kind of thing. Y equals d. That's the midline. Step 3 is mark the y-axis with the peak value and the min value. Peak value is always going to be midline plus amp. The min value is always going to be midline minus amp. So this is how we've started all the graphs we've done so far. You get your line through the middle, and then you figure out how far above and how far below your graph is going to go there. So you get your peaks and your troughs, you know how tall it's going to be. After that, you mark the phase shift. Mark the P shift on the x-axis. That's the start. Oh, that's not step 3, that's step 4. Turns out there are too many steps for me. I'm going to start erasing things from the top. Okay, back around to step 5. Find the end. So this is, I'll put start in quotation marks because these are periodic, they never start or end. But I think we know vaguely what start and end means. So step 5 is you find the end by adding period to P shift. So wherever your P shift is, that's your starting value. It's going to end one period later, so you have to add those together to get your ending point. And then mark the end on the x-axis. So at this point, we should have the midline marked. We should have the peak and the min value marked on the y-axis, so we know how tall it's going to be. We're going to have the start marked on the x-axis and the end marked on the x-axis, so we know how wide it's going to be, where it's going to start and finish. And the last thing we need to do is just figure out what it does within that range by looking at what kind of function it is. So I'll say 7 is figure out what it does. Sine, starts, ends, and middles on the midline. Positive sign goes up then down. Negative sign goes down, then up. Need to erase some more. Cosine doesn't really have the neutral thing. Positive cosine starts and ends at the peak and middles at the trough, the min, negative cosine starts and ends at the min, middles at the peak. I hope that this is clear and understandable as a summary guideline list of what we have done before in our previous examples. Hopefully your understanding is enhanced by the homework problems that we have chosen, that you can access and use the show me an example tools and help me solve these tools. And if you have any questions, I will see you on class time. We can talk about them in a conference. Good luck.